From the audience, today's class shouldn't take very long. Today, we're going to talk about direct variation. Hope you have a pen, don't you? Direct variation. Now, thus far we've been talking about linear functions, and today we're going to still talk about linear functions. The difference being today is this. In a direct variation, suppose I don't buy the pop, I just buy tacos. Okay? And suppose you buy 40 of them, and I buy 10 of them. That's all I tell you. What do you know about my price compared to her price, Brad?
It's going to be less.
How much lower? 40, 10.
3/4
$1 taco.
I don't care, dude. Doesn't matter. They could be $1 million a taco.
3/4 cheaper.
Time out, time out, time out, time out. Whoa, one thing at a time. Brad.
3 tacos.
Oh, no, I know that. But I mean money-wise. How many times more or less do I pay than her? So I know nothing about 30. 30 never not poke his ugly head up. She bought 40 tacos, big fat pig over there. I bought 10. I'm on that. What? Yeah! She spent 4 times more than I did. Is that true? Why is that? Because she didn't buy a pop. There was no extra anything, right? It was just the tacos. Clearly, she spends 4 times. She buys 4 times more of them. It's going to cost her 4 times more. Does it matter how much they are per taco, Rayon? No, it doesn't. They could be $1 million a taco. It could be 2 cents a taco. They could be 50 cents a taco. It makes no difference whatsoever. Now, have we done this before? Of course we have. Mr. Groom, I was going to make cookies the other night. That's what Paige said to me this morning. But the cookie recipe only made like 7 cookies. And I was going to bring them to share with you, Mr. Groom, but my brothers, we're going to eat too many of them, so I quintupled the batch. So instead of using 2 cups of flour, she's going to use how many? Quintuple. 10 cups of flour. That's right, exactly. She's phenomenal. That's why I picked on you. That's right. We've been doing this forever, am I right? Forever. Yeah, is that very hard? No. Does it sound like it's a linear function? Kinda. Kind of. And so what it's going to look like today is this. Y equals kx. Well, Mr. Groom, doesn't that look an awful lot like y equals mx plus b? It does, right? What's missing?
Plus B.
Oh, it's there. What is it?
0.
It's 0. It's 0. Which will be that way every single time. When we do direct variation, sometimes called direct proportions, by the way, the y-intercept is always 0. Right? And if you think about it, as x gets larger, so does y proportionally. Right? To keep the same proportions. Right ahead. Where are you going? Just curious. Library? Cool. Bye. See you. Thanks, Dad. Alright. We good with that? Now, what else do you notice has changed? So the b goes to, it's just 0, and we're doing direct variation. What else has changed? M changes to k. It's kind of like Jessica going home and changing into a blue shirt. Is it still Jessica? Yeah. Is k still the same thing as a slope? Yeah. Why is that? Because it's still times by x. Okay? So in reality, they're the same thing, yes? Now, if this thing has a plus 0 here, what is it going to look like every single time? It's going to look something like this. Because it's going to go through the origin every single time. Okay? Not this guy. This guy. Okay? You with me on that? That guy's going to look at that every single stinky time. Every time. Take it to the bank. You with me on that, Brad? Doesn't matter what it is. Now, why do we call it k, Mr. Groom? I'll tell you why. Y equals kx. K is what's called the constant of proportionality. It's not going to change. Does it matter how much the tacos were? Not one single stinking bit. All that matters is they stay the same price. Okay? Stay constant. That's right. Drive down the highway, cruise control, I mean, here's why I put cruise control on. Not for better gas mileage, because if I'm listening to talk radio and I get pissed off, I tend to drive faster. If I'm listening to a sweet, kind of a go fast kind of a song, I tend to drive faster. If it's kind of a slow, ballady sort of thing, I tend to slow down. If I'm driving along and there's some cool piece of farm equipment out there, I tend to slow down. Look at it. That's just how I am when I drive. I'm kind of all over the map when I drive, kind of like when I talk or teach or anything else. I'm just kind of everywhere, dude, all the time.
Yeah, once you pass on the highway, I swear you're doing like 80.
Probably. And then I probably got less pissed off than I was listening to radio eventually, Grant, and I probably slowed back down to 42. Right after we first married, the wife was following me somewhere. She got so mad. We had her, what were you doing? I'm like, what are you talking about? Oh my God, you were doing 85 and you were doing 40. I'm like, nuh-uh. It's like you were all over the map. I'm like, So I just put cruise control on when I have a boss. Okay? Then I just, cruise that way. I don't think about it. Then I can get mad at what's on the radio. I can get, whatever. But the car, same speed. Okay? Less tickets that way. You're on time. Especially sometimes when the wife is in the car, she'll listen to some cute trees, which I can tolerate for a couple of songs. But if I have to listen to that for very long, we're driving on Highway 35. It's so mellow. Right? But by the same token, if I put on too hardcore of music, then I get to explain myself. You were going to say? Somebody going to say something like that on you? No? Sweet. So, point is, it's constant. Okay? So, y equals 60x. Here I am driving down the highway, 60 miles an hour. Sweet deal. Here I go. Lovely. 1 hour. How far do I go? 60 miles. That's awesome. What if I don't go? Katie, how far did I go? Both of you. Perfect answer. Nowhere. Don't drive for any time? Yeah, you don't go anywhere yet, obviously. All right? Am I right? Duh. Duh. Drive for 3 hours, you go 3 times as far, which in this case is 180 miles. Right? Piece of cake. Oh my gosh. Hard? No. Rocket science? Well, kind of. Actually, yes, it is. But no. Is it hard? No. Here we go. Down the road. Hey, let's double the batch of cookies. Great. You're going to have 14 volleyball teams, and each team has 10 people. Well, duh. It's 10 times. Obviously. If I have 0 volleyball teams, it's 0 players. If I have 14 of them, that's 140 players. It's 14 times as many. It's so easy. Boring. Now, what we are going to use it for precisely today is this. We are going to say this. Suppose y varies directly as x. Now, by the way, we will use this terminology a lot in science class, yes? A lot. Oh, my goodness, a lot. For instance, there's Boyles law. Not Boyles law. One of them will come to me in a minute, right? I'll come to me and then we'll deal with it at that point. But when we get to it, it's the idea that how are those two things related to each other? And it's very much of a direct variation of them. Varies directly as x. Okay, so what that means is this. Y equals kx. We know that to be true. Okay? Then what it's going to be asked you is this, Amanda. If y equals 92 when x equals 16, find x when y is 81. Now, first thing that comes to my mind is this. I like math because I know if I'm right or wrong. Okay? I might be wrong and I might not know how to fix it, Stephen. Dad, no, but I know I'm wrong. There's no, maybe I'll get it right. Oh, I wonder what I got on the test. I wonder if I did good. You're lying to yourself. Okay? When you leave here after a test, Rebecca, you should know, I got an A. I got a C. Oh, I failed miserably. But you shouldn't go out, God, it's like Christmas. I wonder what I'm going to get. You should not at all. Now, if you did cruddy, you get about half of them right or something, in your mind you should be going, oh, I got about half of them right. 50%, that's math. Okay, yes. No, please, yeah. So the first thing that I like about this is this. Hey, look at my y's. It went from 92 to 81. right? It went down a little bit. Oh, wow, a little bit, right? What's going to happen to my x's? It's going to go down. That's right. So not if you screw it up. When you screw it up, because it will happen. All right? I mean, you'd be, oh, I know. Oh, I know. Oh, I know. Oh, I'm doing math at the same time. Oh, I know. Oh, whatever. LOL. And you screw it up, and you will. What's going to happen? When you screw this up, when you screw it up, you'll get an x like of 27. It doesn't make sense. How could the y's go down and the x get bigger if they varied the same direction? That should not happen. Okay? So just keep that in the old front of the mind, not the back of your mind, in the front of your mind. Okay? Is that what you're going to say?
No, I was just trying to figure
Okay, cool. Okay, so how do we go about solving this cat? Yes?
92 over 81 equals...
Whoa, hold the phone. There's a couple ways to do it, okay? A couple ways to do it. And he's going to go the second way first. But Warner might do this. She might go, you know what, Mr. Groom? This looks like a y, and this looks like an x. And so, she could solve for k. And that seems reasonable, yes? We'll get to your way in a minute, okay? And so we could divide. So we would get k is equal to 5.75. Seriously? Sweet. 5.75. Good for us. Ah, great. That's nice. Did I really care about that k value? No. I really want to know what? I want to know x. So I would say 81 is equal to 5.75 times x. Right? And I would divide. And then I would get x is equal to, I don't really care. Round it off a couple decimal places. What do you get? 14.1. 14.1. Lovely. It's not plutonium. I don't need 14 decimal places. Okay? 14.1. I get the gist of it. Okay? I know where you're at. 14.1. That's it. Does that sound reasonable?
Yeah.
Ah, it went down. Ah. Now, Brad, we did an intermediate step. Brad, we found k. We found the constant of proportionality. On your homework tonight, there are, I think, 3 types of problems. Find a constant of proportionality, find x and the constant of proportionality, and simply find x. So I did it this way just because sometimes you're going to be asked to find the constant of proportionality. There it is. I did it. Now, is there a better way? Is there a different way? There's a different way. Is it better? I don't know. Is it a different way? And what is it there? Go ahead. What is it? Go ahead. You're going to tell me, Josh. Go ahead.
92 over 81 equals...
92 over 80. Let's do 92 over... Can we just do it this way, please? Over 16 is equal to 81 over x. And the reason I do that is this. Watch carefully, please. Y equals kx. Y divided by x is equal to k. Is that true? Now notice, is it any value of y mixed with its value of x? Will it always equal k? Yeah. Yes, it will. So 92 was our y that went with 16 for an x. 16? Yeah. So 92 over 16 should be equal to what? 81 over its x value. And how do we solve these guys? I mean, this is old school, but I do it. Cross multiply and divide. And you should get, lo and behold, what? 14.1. True? So on the part of the assignment where they say, hey, just solve for x or solve for y, knock yourself out. Do a little cross multiplication. Awesome. Okay? If they ask for the constant proportionality, you got to go this route anyways eventually. So, whatever. Whatever. Get her done.
But when you find the constant, why can't you just do y divided by x?
You can't. Well, that's what she did. By the way, time out. Time out. It's a great question, Beatrice. She said, well, Mr. why couldn't I just divide 92 by 16? That's how we found it up here, right? I'm just showing you. I'm just saying. Okay, that's how we got there. Some people maybe haven't remembered that. You're a little smarter than us. Hannah, you're a genius. Check it out. Look, isn't that what we did right here? Isn't that y over x?
Yeah.
That's all it is, dude. You're way ahead. You're like 6 miles ahead of me. All right, we'll catch up, I promise. We'll try to catch up to you. Now watch carefully. So let's suppose for a second, what's your favorite Greek letter? Mr. Rial. Yeah. Sigma, too late. Suppose sigma varies directly as star. Oops, that's not a star. Okay? Don't panic. Don't panic. Nobody cry. Who's our y in this case? Sigma is equal to k times star.
Wait, how do you know that thing?
So listen carefully. Oh, how do I know sigma?
No, how do you know sigma's y? Or you just
Okay, so listen carefully. So on the previous page we wrote, suppose y varies directly as x. So when I switch it up and use a different variable like j and q or star and sigma, the one that varies directly as the other one, so in this case sigma varies directly as star, sigma is y, and star happens to be x. Okay? The other way of knowing it is this. Okay? Again, it comes back to the price and the taco, right? You walk up to the idiot box, what has to happen before anything else has to happen? You have to order. You have to tell me, Kayla, I want 3 tacos. So what varies in that case? Does the price vary with the tacos, or the tacos vary with the price?
Tacos vary with the price. Or
That would be the lady going, dude, you're going to spend $5. Okay, I guess I want 12 tacos. The price varies with tacos, right? Who is our y value? The price or the tacos? The price is. Why is that? Because x has to happen first, right? Same thing here. Now, again, so watch carefully. So if star equals 9 when sigma equals 31, find star when sigma equals 8,031. Sweet. So our sigma got kind of big. Pretty darn big, actually, right? So our star ought to get pretty darn big too, correct? Comparatively speaking. How would I set it up? Go ahead, Grant. Let's do it this way, Grant. How would I set it up?
you put the sigma on
Okay, and what sigma number are you going to use there, Stud? Pick a number.
any number?
No, one of those 2 numbers over there for sigma. Which one are you going to use?
31.
So 31. 31 over what?
9.
9. Does that make sense? Amanda? Amanda? Does this make sense? This sigma goes with this star, right? This y goes with this x. That makes sense, right? So on this side, what are we going to put? We have sigma over star here, or if you prefer, y over x. So what's going to go over here? We know 8,031, don't we? We're doing it cross multiplication and divide way. Okay? What? What?
It's fine, never mind.
Over what? Over star. Right? Sigma over star, if you prefer, it's y over x. Okay. And y over x. You with me then? Cross multiply and divide?
2,331.
2,331. Does that sound reasonable?
0.58.
2,331 point blah. I don't care.
58.
Okay? Does that sound reasonable?
yep.
Does to me. Okay? Look what happened over here. We're like, I don't know, 30 odd times bigger over here. We ought to be 30 whatever times, 300 whatever times bigger over here. It's big. Does everyone corroborate that story with her? Good. All right, now, another way to look at it here, this is about 3.5 times bigger on the top over here. This is almost 3.5 times that size there, right? Okay, about. Okay, so a couple of ways to go. The big deal is this. You people will get so confused about this tonight. But remember, when it says y varies directly as x. It doesn't matter what it is. This variable right here, whatever variable we mentioned first, like this, is going to be our y value. Whatever variable we have over here, it's going to be our x value. Remember back to 6th grade, they put one of these on the board and say, today, we're going to talk about this distance across the circle. What is that called?
Diameter.
And how is the diameter related to the circumference?
Pi radius.
Circumference is equal to what?
Radius squared.
It's area.
Pi times 2 radius.
Pi times diameter. Yeah, I know. Huh. Check it out. What does that look like to you? Doesn't that look like y equals kx?
Yeah.
Doesn't it? Shut up. You're being weird. Doesn't it, though? It does. When you were back in the day, if you were a Greek guy back before they figured out what pi was, could you still, like, know, for instance, Katie has this cute little thing here, but she wants to, like, oh my god, I don't know, 4 times bigger. Good for her, for whatever reason. Oh my gosh, Katie. I wonder how much stuff I'm going to need to have. Well, I don't know, probably what? 4 times more. Do you care what pi is? You're completely clueless about pi. You don't even care. All you know is you measured this. This is 10. This is 40. That's cool. You know this is like 31 point whatever. Great. So can you find this one over here? Of course you can. It's 31 point whatever divided by 10 is equal to, I don't know, divided by 40. You cross multiply, you divide, and lo and behold, it's 4 times this thing. 124 point whatever. Okay? Were you happily ignorant of what pi was? Do you need to know the constant of proportionality? Don't need it at all in that case. Okay?
So I have to find the constant when it says.
Yeah. That's exactly right. That's exactly right. Now, listen carefully, Decius. This one is for you. Are you listening, Decius? Good. Yeah. Is that a direct variation? Yeah. Is it?
Well, like, I know the first couple ones, like, there's like the x, or the y is
Say what now?
I don't know.
Say that again.
So
Say it again.
because, like, the first couple ones, the y is 4 times 4.
Now wait a minute. Wait a minute. Are you telling me that this thing seems to be obeying this little thing right here, like that? Is that what you're saying? Is that what you're saying to me? Okay, what is my general rule for answering questions? Don't answer the question like I'm going to beat you if you get the wrong answer. Yes, oh my gosh, don't hit me! No. My rule is you just answer the question. I know they're calling me, I don't care. Now, y equals 4x. Okay? Now, let's solve this thing. In other words, y divided by x is equal to 4. Is that true?
Yeah.
It is for the first couple, correct? In other words, y divided by x is equal to what? A constant. Right? Now the question is, does that hold true all the way down the page?
I don't think so.
What do you mean you don't think so? 80 divided by 20 is 4.
It does.
124 divided by 31 is?
Oh.
Okay.
And 1,028 divided by 257 is?
Oh.
So is it a direct variation? Yeah. Yes, it is. Yes, it is. Because, shh, carefully, because this divided by x is equal to a constant. Because of that, it's a direct variation. Shh. Now, great. I don't know. Now is it? No. How many does it take to screw it up?
So you would just say no
It is, you would say, is it a direct variation? You'd go, no. Duh, screw. This is Jessica vernacular. No. No. It's not like that. I don't know how you write it, but that's what you'd say. Yeah, and one of those too. Yeah, you'd say no. No, it's not. Okay? Alright. Questions, comments, concerns on that kind of a deal? What I'd like to do is you have about 15 minutes left of class, unless I miss my guess. Ish. To work. To answer questions. To ask questions. I'm going to write the problems that you're missing from section 1.2 on the board. Because apparently we didn't get some coffee. I say we, I mean her.